So I think before the coffee break, we have now this Q&A session. And I see one question for Jean-Noël. Basically, how challenging it currently is to do your development work across different systems.
So there are several aspects here. The first one is, fortunately, we had a colleague in our team who very early on in the ESPResSo history decided to emulate major CPU architecture so that we would make sure ESPResSo would always be like almost always correct in floating point precision issues and algorithms like that. Nowadays, we have like several techniques. First of all, we are using a large body of consumer-grade CPUs, both on-site and in the cloud, to make sure that ESPResSo is like working well on as many consumer-grade products as possible. And we get feedback from online services like Fedora and OpenSUSE when something was wrong. We also have access to clusters. We have our own EuroHPC cluster here with modern Zen 4 architecture. We have access to one EuroHPC GU system called Vega, where we do most of the development because it's relevant for the application of ESPResSo. We recently got access to Snalius to I troubleshoot some issues there as well recently. And the future of like writing code is slightly changing. Like nowadays, compilers are very good at figuring out for you which are the correct optimizations. And in ESPResSo, we're also experimenting with this waLBerla LBMPy pipeline where you write down the mathematical equations of your lattice-based method, and it will generate for you code in the C, C++, CUDA, or AMD languages, depending on whether you target CPU or GPU. And this pipeline is clever. It will realize, oh, I can use these specific AVX2, AVX512, or this IRM neon vectorization data types to write down very hard to read, but very optimized code for you. And you as a developer don't have to read this code. You just have to write down the mathematical equations and then write a call to the function. And this way you can target multiple CPU architectures and multiple GPU vendors without having to spend too much time coding. I hope this answers the question.
Thank you. And there is another question for Alan. Actually, you showed this application of PyMBE for ESPResSo. So what is the status for other codes like LAMMPS and waLBerla? And then now, of course, this is just one package. And then, I mean, when we will have all the workflows ready, you will have to combine all these packages together. So how do you envision this application? So does this make a challenge or not, or it's easy to just not?
So in terms of CI, so lots of big applications like the ones you mentioned, right, like LAMMPS and waLBerla, they have extensive CI already and that they do themselves. What we're trying to do is help applications, including them potentially, but help applications in general get this CI concept integrated into their applications early on, because it should be an integral part of what they do, right? So one of the reasons that I'm so keen to push this as a service is because it is a best practice, right? It shouldn't be a technical burden for people to be able to use these concepts even when developing code, right? So I want to encourage people to use platforms like GitHub, GitLab, and similar platforms to develop code, because I want them to do things like pull requests. I want them to do things like merge requests, because this is important, right? This social part of developing an application and reviewing code is a critical part of the development, right? It will catch problems, and having a second pair of eyes look at the code that you're developing and breaking it down into small pieces that somebody else can consume is a good thing for application developers. And it will ultimately, sometimes people feel like, especially when they start out, that this is slowing them down, right? That they could be much faster if they just did their thing and did their work and run their code. But in reality, when you take a long-term perspective, that's usually not true. because usually people make a mistake, right? It happens, right? People make mistakes. They introduce a bug. They don't recognize that the bug is there when they introduce it because for some reason, whatever test case they might be using, if they're using a test case, doesn't touch that part of the code. But then at some point, this bug appears, and then people spend days or weeks trying to figure out at what point was this problem introduced and how do I fix it? And this is time consuming. And I've been there. I've been that person, right, who was developing an application when I was doing my PhD, and I had never heard of GitHub repositories. I'd never heard of CI. I didn't do any testing. I just wrote code and tried to run it. And if it didn't work, I went print statements, print statement here, print statement there to see what's going on where. And that is in reality a very slow and time consuming process. And you're much better off if you have to start in the right way. So start small, start integrating these things into how you develop code. And in the end, you will save time, and you will save a lot of time. And the reality is that's also how other people develop code. So it's in your interest to learn this process, because if you ever want to contribute to somebody else's application, this is what you're going to have to do anyway. So you need to get familiar with these tools. You need to get familiar with this social coding. You need to get familiar with Git. You need to get familiar with what CI is, what it does. Because if you want to work together, this is the way most people do it, right? So it's important to do that. So what we provide is just a tool to help you to do that, to make that as easy as possible for you. And this is what it's when I talk about this productivity, this is what I mean. That we want to provide tools that are useful to people, that will do a job, that will allow them to develop applications and do it quickly. And the other thing that we do is, I mean, it's not part of the CI thing, because the reality is that the CI tooling will work wherever, will be running wherever that CI is running. So in GitLab right now, or GitHub, that's in Azure, right? It is, yeah, it's Azure, right? So it runs in Azure and it's typically like, I think it's Zen 2 or Zen 3 or something like that, where your CI is running. So you're not testing multiple architectures there. You're just testing that for specific architecture. One of the big problems is if you're talking about developing code for EuroHPC, that's not enough. You need to test your code on lots of different architectures, and that is a complicated problem. And so what we want to do is try and help to solve also that issue, right? So by integrating your application, like Jean-Noel has done, into EESSI, we automatically test that production application across all these different architectures, and then we will report problems, right? And don't think that if there is a problem, you're not alone. Okay, many applications, big applications that have existed for a long time, also have problems, right? Because they don't have access to these infrastructures to test every single combination, right? But what we're interested in is testing at least on the EuroHPC systems that are relevant there, but we go beyond that too. And so by the application having a good test suite, and by us running that test suite on all these different architectures, we expose problems. And we've seen that even on like production applications from centers of excellence, right? Nobody's perfect. And the sooner you start addressing these, typically they're small problems, but the sooner you recognize them, especially in your development process, that you recognize these issues, the sooner you can solve them, and then you won't see them anymore, right? So once you've solved these things, especially if you do it incrementally, what you don't want is that you go and develop your entire application on Zen 2, and then you run it on ARM, and lots of things are broken, and it becomes a big burden to think about, oh, now I have to do all the vectorization on ARM again, and it's different to how I did it on the other architecture. And that is painful for people, right? And that's why people don't port between different architectures, because it's hard, or it can be hard, especially if you don't do it incrementally. It becomes one big job that you do at the end. And it's the same, like Jean-Noel said, for the GPUs. It's the same, right? In the terms of CUDA, you think about CUDA. If I do everything in CUDA, and then somebody says, here's a supercomputer with AMD GPUs, and then you say, well, now what do I do? Now I have to start again from scratch. Oh, that's so much trouble. I can't do that, right?
Yeah.
So that's why we have to think about other applications, other ways of addressing these problems.
Sorry, Alan, to interrupt you. I just wanted to say, so you already mentioned that this is very important if you have like a collaboration between different groups, like in our consortium. So this is important for our consortium to develop all these workflows and codes, but it will be also extremely important when people will start adopting our workflows and codes later on, once we provide the stack. And yeah, so to have all this continuous development and integration, it's extremely important for the sustainability of the software. And actually, it's crucial that it takes up by the community all this, all our efforts. It's actually they are based. So our dream is that basically we are providing this code for all CECAM community, and then they can then adapt this code and workflows for their problems that might not be exactly the same as we are showcasing it now here, but they are similar enough so that the code can be then adapted and workflows for their particular problems. Especially because this is really to tackle the exascale supercomputing, which is not the expertise of all the groups within the CECAM community. Any other questions? I don't see any. So I would suggest that we then reconvene at 11. We have now a coffee break, and at 11, Tilen will show us their efforts about ultrasound modeling and application to the biomedical problems. So see you at 11. Thank you.